Right, so you've looked at the Gizmo simulation, and now what I'd like you to do is create another simulation using a spreadsheet. Um, Pretty much, you may have access to hopefully you have access to a spreadsheet, some kind of spreadsheet software, and they all pretty much work the same. So it doesn't matter if you're using a Mac or a PC. Uh, there's also on the LMS, you'll see the Office 365, which has an Excel, although it's stripped down, but probably for the course, you're probably going to be able to get by with what's on there. Now, what you're going to do is make up a heading where we've got die 1. And in the first cell, we're going to put equals rand between. And you'll see that it comes up as a formula. And since we're going to be rolling a 6-sided die, the bottom number is going to be a 1, and the top number is going to be a 6. So what this formula does is return a number between 1 and 6, a random number. So it's just like rolling a die. And every time you copy over a type in the cell, so if I type A here, you'll notice that the numbers change. So every time you do anything, the numbers automatically change. So what I'd like you to do in cell D1, sorry, D2, you're going to put equals, and it's going to be this cell, B2, plus this cell, C2. And that returns in the sum of what's in these two cells. And what I want to do is copy this down so that we've rolled the dice 10 times. So I'm going to go down to D11, and you'll notice that in every case you'll have 2 die rolled and the sum of them. So what I want to do now is I want to see how many I have total in this table. So I'm going to actually create a table here, and we'll go to tables, and you can pick any type of table you want, and I'll show you in a second why that's a big advantage to put all your information into a table. So I'm going to, in this cell, I'm going to put equals count. And so what this function does is it counts all the number of values in this table. And so what I want to know is how many sums do I have? And the answer is 10. And I'll show you in a second why I want that. So now what I want to do is I want to see how many of each sum there is. So I'm going to just type sum, and it's going to be 2, 3, and then what I'm going to do, instead of typing out all the way up to 12, I'm going to take the corner of this grid and drag down till I get to 12. And now I want to look at how many times each value comes up. So I'm going to put in a heading for frequency. And here, in this cell, I'm going to put down equals, and this time I'm going to use a different function for counting, and it's count if, and this, my range is going to be the sums. So I notice you go over to the table, you'll notice that there's a little black arrow, and that will take all of the values in the sum. So my criteria for the first one is going to be put in a comma, and then in quotation marks I put 2. And you'll notice that we have no 2's in this table. So what I'm going to do now is I'm going to drag down. So we still have no 2's in our table. So I'm going to start changing this value, the criteria, in every case. So I'm going to change the first one to a 3. Then the next one, I'm going to change to a 4, and so on. So now I'm counting all the frequencies of all of the dice rolls in my table. So if you go over to the table, you'll notice that 3 is the frequency for 7. So there's 1, 2, 3 7s. We also have 3 10s. 1, 2, 3. So my formula is working. Now, how this works well is what I can do, since we only have 10, that's not much of a sample. And remember, back in the gizmo, the more times you run a simulation, the more trials you have, the more your experimental probability reflects the theoretical probability. So I'm going to insert a chart here. Now, what works well is if you, first of all, pick scatter or XY scatter, right? And so what this does is it returns a frequency histogram or a frequency scatter plot. But now I want to change this to a column, and there's all sorts of different ones you can select. And I can also format this. So if I want to do a quick layout here, I want something with a title like that. So now I can change my title to frequency of rolling 2 dice. And here, I can change the title, the axis to this frequency. And on this one, it'll be the sum. All right, so as you can see, if we now create a theoretical probability. So if I copy this column, so this is going to be our theoretical probability. And if I want to expand my column, I just double click on the column. And so here I'm going to put equals, it's going to be 1 out of 36 probability of rolling a 2. And you'll notice that every time I type, my frequency is changing. And I'll show you what you can do just shortly if you don't want it to change. All right, so here is the theoretical probability of rolling each sum. And so if I'm going to create a chart doing this, using this, again, I first start off with the scatter plot because it seems to work better. And then I'll change it to some sort of column. And in the quick layouts, the chart styles, there's all sorts of different styles you can pick. And if there's something you like a little bit better, There you go. And if I want, again, to put in headings, so, and I would like you to do this for all of your charts, have some, make sure your axis is labeled, and you have a title. All right, so as you can see, this is our theoretical probability, and in 10 trials, our experimental probability looks nothing like it. So the way we can fix that is by going over to the table here, and I'm highlighting all the cells that contain numbers, contain values, and I'm going to take the bottom corner of this in this table, and I'm going to drag it down one. And you'll notice now here we have 11 values. So the great thing about a spreadsheet is I can keep doing this, and I can drag down so that I get hundreds or thousands of simulations. So this would be like rolling a dice over 1,000 times. So if I go back up to the top of the table, tap the spreadsheet, my frequency here is I've got 1,543 simulations. And you'll notice here, our data is starting to look more like the theoretical probability. So what I'm going to do now is I'm going to figure out the relative frequency. Or actually, I'll call it, you can call it relative frequency, or I'm going to call it here, what it really is experimental probability. And I'll just widen this. Now, all I have to do for this is I'm going to press equals, and that's the frequency of 2's divided by our number here. So that's the total number of trials. And I get an experimental probability of 0.026, which is very close to the theoretical probability of 0.27 repeating. So what happens now, if I copy down, you'll notice it ends up being an error. And the reason is because when you drag down, it automatically changes the formula. So here, it's dividing the value in H5, which is the frequency of 3's that were rolled. Problem is, when you drag down, it goes to the next cell down for the count. So what I'm going to do now is go back up to this, and in my formula, I'm going to put a $sign in front of the 1. And this is called a global reference. So now, when I drag down, it always divides by the value in this cell. So in every case, we're dividing by G1. So now, if you take a look at the relative frequency, or the experimental probability, it becomes a lot closer to the theoretical probability. So I can chart this, and on a Mac, you highlight the cells, and you press Command, and on PCs, it's Control. So I've got my sum column highlighted, as well as my experimental probability, and I'm going to create a chart of that. So there's my experimental probability, and I'm going to change it to a column, and I can want you to put in a title again. Don't want that there. And I can change my chart type to something a little bit better. So here is a comparison of our theoretical experimental probability and our theoretical probability. And obviously, the more trials you run, the more closely your experimental probability is to the theoretical probability. So what I'd like you to do now is practice this, make up a spreadsheet using just what I have done here, and try it out.